In question 3, this object fired up the frictionless ramp has an initial velocity of 35 meters per second. Now it's useful again to work in the components. So we're only really interested in the component of the acceleration that acts down the slope, because the amount of it that is acting into the slope, like that, is of no value. It doesn't speed up it up at all. So we have V naught is equal to 35 meters per second. Vf will be equal to negative 35 meters per second as it comes back down. We want to know what the acceleration is. Well, the acceleration is equal to 9.8 multiplied by the sine of 65 degrees. This gives us the component of the acceleration acting down the slope, 8.9 meters per second squared. Now we move over to another formula. So Vf is equal to V naught plus At. We remember that is going to be solved for t. So t is equal to Vf minus V naught, all divided by A. We have everything we need now. So negative 35 minus 35 divided by negative 8.9. We used our direction there to get that, the convention of down being negative. Works out to 7.9 seconds. That's a good choice, 7.9. That's right. Oh, I managed to somehow zoom through this. Alright, so 7.9. Question number 4. This one's really just understanding what's going on here. Since the horizontal displacement is what's in question here, we have to remember that since the vertical component of the velocity is constant, we should expect a linear relationship when it comes to the displacement. So our choice is clear. We have to pick D. In question number 5, we have this projectile that's launched at 35 degrees above the horizontal. And let's just draw that. 35 degrees above horizontal. And it's 120 meters per second launch speed. And we want to know what is Vx and what is Vy. So Vx is equal to 120 times the cosine of 35, or 98.3, and Vy is equal to 120 times the sine of 35, and that works out to 68.8. Now, one of these is going to stay constant. Hopefully you know which one that is. The Vx is 98.3. What we want to know is, after a given amount of time, what is the y component of the velocity? So 3 seconds later. Well, the only way we can figure out that is by applying what we know about the acceleration to the y direction of the motion. So Vy is going to be influenced by the fact that at the top of the curve, again, we would have no speed, but 3 seconds later we can say, well, Vyf is equal to Vy naught plus negative 9.8, or g, times t. I probably could have left everything in there, but I didn't. Vf is equal to then the 68.8 minus the 9.8 times the 3. When you solve this, it works out that y is equal to 30 39.4 meters per second. When we apply Pythagoras' theorem, and we have 98.3 across the bottom, and we have 39.4 acting vertically, a little bit of a squared plus b squared equals c squared gives us a speed of 106 meters per second. C. All right, sound good?